Engineering is defined as that phase of highway engineering, which deals with the planning and design of highway and with the traffic operation thereon for the safe, convenient, and economic transportation of persons and goods. And in traffic engineering, we study traffic characteristics, traffic studies, and its analysis, traffic control, and regulation. So now here we will see some traffic engineering concepts by answering some 10 questions, which are important in examinations. Now let's get into it. First question is based on desire line diagram. In the desire line diagram, so what is the correct option? Width of the desired line is proportional to the number of trips in one direction. Length of desired line is proportional to number of trips in one direction. And C, width is proportional to both the direction, and both width and length of desired line is proportional to number of trips in both directions. So what is the correct answer with respect to desired line in desired line diagram? Actually, desired line diagram is found in OD studies, origin and destination studies, we can say. So the desired line is nothing but a line in which the width of that line, width of desired line, is proportional to the number of trips in both the directions. So you can see in this diagram, so this line has more width. This line has some more width. That means this trip, this origination and destination trip has more number of traffic. That is, more number of trips are uh, doing here within these two locations. So that's why width of this desired line is higher than other things. Now let's see more about O&D studies, origin and destination. So desired lines are graphical representation of O&D survey. Straight lines connecting origin and destination. So these are straight lines that connect origin and destination. So you can see in this line is very thin. That means origin and destination between these two locations are very less in terms of number of trips. And how it is conducted, how this survey is conducted by some methods like roadside interview, license plate method, written postcard method, tag on car method, home interview, work spot interview method. So by interviewing the people's traveling in these directions and in this trip, we can find what is the intensity of this trip. And by using license plate method, written postcard method, and tag on car, and we can place a tag in the origin car, and that tag will be calculated in the destination, so that how many number of trips are going in this within these two locations. So this is how we can find origin, destination, and desired line width. And how OND is presented by using OND table, desired line, pie charts, contour lines. So desired line is one of the most likely used in OND survey. And other than those, table, pie charts, contour lines are also used to present the origin and destination survey. Now let's move on to second question. A road has free main speed of 50 km per hour and have average spacing between the vehicle under jam condition. Under jam condition means under full traffic. That average spacing is given as 5 meter. We have to find the maximum flow in terms of vehicle per hour per lane. So how to calculate that? By using Green's theorem. By using Green's model or Green's macroscopic analysis, we can find the answer for this question. So for options, pause this video and calculate using Green's macroscopic model to get the answer for maximum flow in terms of vehicle per hour per lane. They have given two data, 50 km per hour, and the spacing in jam condition is 5 meter. So the correct option is option B, 2500 vehicles per hour per lane. Now let's see how it is calculated. So Greenshield method is nothing but this formula. It is a macroscopic model of traffic analysis. So U is equal to U suffix SF into 1 minus K by Kj. So what is USF? USF is free mean speed. They have given in the question. Free mean speed is 50 km/h, and K and Kj are related to density, that is traffic condition. In jam condition we can denote as Kj, and Ks in normal condition. And what is the capacity? That will be given by this formula, U into K. So jam density is given by this formula, Ks of xj is equal to 1000 by average spacing, and average spacing is given as 5 meter, so 1000 by 5, 200. For maximum traffic volume, they have asked for maximum flow. So for maximum traffic volume, we have to differentiate the Q value with respect to density, with respect to K value. So dq by dk is equal to 0. That means, so if you Q is equal to uk, we know what is U. U is U equals to USF into 1 minus K by Kj. So what is small q? U minus um, USF minus U square K square by Kj, because here on K is there. So USF into K minus K square by Kj will be arrived. So on differentiating that equation, we get this as the answer. USF into 1 minus, that is K square, right? Because K square by Kj. So on differentiation, that will become 2K by Kj equals to 0. Now USF can be cancelled out, and 1 minus 2K by Kj equals to 0. So we can rearrange this to form this formula. K is equal to Kj by 2. Under normal condition, the density is K minus jam condition, half of the jam condition. Under normal condition, density is nothing but half of jam condition. We can remember this equation also. And for in jam condition, the maximum capacity shall be given by this formula, USF into K by 4, or we can say like this: at maximum condition, velocity shall be half of free mean speed, and at maximum condition, the jam density, or the normal density of traffic, shall be half of the jam density. So that's why USF by 2 into K by 2, that is nothing but USF into K by 4. So we know what is USF, 50 km/h, into K. What is K? Kj by 2. Kj is nothing but 200. So 200 by 2, 100. So USF into K by 4, that gives us answer as 2500 vehicle per hour. So you can see in these three graphical illustrations using Greenshield method. So first graph is for speed versus density. So you can draw a line here about it. Speed versus density graph, and second graph is speed versus flow, and third graph is flow versus density. And at Kj by 2, actually K jam is here, that is jam density, and half of the jam density corresponds to half of the free mean speed. So that's the normal speed. And at jam density, the speed will be negligible, 0, because all vehicles will get stopped at full jam condition. And it comes to second graph, speed versus flow. So flow, when flow is maximum, then speed is denoted as U. When flow is 0, or we can say jam condition, then it is denoted as UF. So, and third graph is Q versus density. You can see here. So at K max, K max means it's a free condition, free flow condition, and here K jam, that is jam condition. So at free flow condition, maximum flow will occur. So at maximum flow, speed will be maximum. That's all. So we can find these graphs that are useful to get the answers for these formulas or equations. K is equal to Kj by 2. Maximum traffic volume is given by dq by dk equal to 0, and if we differentiate that Greenshield method equation, we get this formula, USF into 1 minus 2k by kj. So this is how we have to calculate the Q max, that is the maximum flow. And other two macroscopic methods are Greenberg model and Underwood model. Greenberg model is given by this equation. U is equal to USF natural logarithm into kj by k. And for Underwood, U is equal to USF E power minus k by kj. So these are some of the other macroscopic model, but basically usually we follow only Greenshield macroscopic model to identify the maximum flow in a corresponding section of highway. Now let's move on to third question. An observer traveling at a constant speed of 70 km per hour with the traffic stream over a 5 km stretch is passed by 17 vehicles more than what he passes. So this question is based on floating car method. This question is purely based on floating car method. They have given some data regarding that. So and number of vehicles meet in opposite direction is 303. The flow of traffic stream is. So by using the given data in the floating car method, we have to find the flow of traffic stream. So they have given speed, they have given the length of stretch, they have given opposite direction met in number of vehicles met in opposite direction, and passed overtaken vehicles. So by using that floating car formula, we can find the answer. The flow of traffic stream in this scenario is option B, 2240 vehicle per hour. Now let's see how it is calculated. So floating car method goes by like this. Q is equal to n suffix a plus ny divided by ta plus tw. So a represents against. Y means difference between average overtaking minus average overtaken in the direction of flow. And w t suffix w represents along with. So along with the string. So you can see here what is NA, TA, TW. NA means number of vehicle counted in the direction of stream. In the direction of stream, when test vehicle travels in opposite direction, that means test vehicle is against the direction. So that's why N suffix A. Number of vehicles counted in the direction of stream when the test vehicle travels in opposite direction. And NY is nothing but difference between average overtaking and overtaken in the direction of flow. And ta is nothing but average journey time. This is a, that means traveling against. So a floating car, for example, take this as floating car and other traffic and conditions prevailing. So this car, based on this car, floating car, we are getting these four values: NA, NY, TA, and TW. TW is nothing but average journey time along with the stream. So along with the stream, what is the time? So that is the TW, and TA is traveling against the stream. So this is the against the stream. Just consider that is nothing but TA. So this is how we have to calculate the four values NA plus NY divided by TA plus TW by using some data relevant to the floating car method. In this problem, in this scenario, they have given what NA value and NY, TA, TW, all the things given. So number of vehicles meet in opposite direction is nothing but NA. So NA is 303 and NY also they have given us 17. 17 vehicles more than what it passes. That is nothing but the difference between average overtaking and overtaken. So that is nothing but 17. So 303 plus 17 divided by time or divided by time. Time is nothing but uh, distance. Okay, distance by speed. That gives the time. So 5 kilometer is the length of stretch divided by speed is given in 70 kilometers per hour. So 5 by 70 is the time and it is given as constant speed. So that means TA is equal to TW. Whatever the time average journey time taken against the stream is equal to the journey time along with the stream. So that's why 5 by 70 for TA also and TW also 5 by 70. So 303 plus 17 divided by 2 times of 5 by 70. That gives the answer as 2240 vehicles per hour. Now let's see another important formula regarding floating car method. the average journey time. So how to calculate the average journey time? By using this formula, T bar is equal to TW minus NY by Q. TW minus NY by Q. So these are some important two formulas. So first one is Q formula. Q is equal to NA plus NY by TA plus TW, and the journey time formula. Now let's move on to fourth question. The highway facilities are generally designed for option A 15th percentile speed, option B 30th highest hourly volume, option C 29th highest hourly volume, option D annual average hourly volume. So what is the criteria that are usually uh, applied to design highway facilities? So whether it is 15th percentile speed or 30th highest hourly volume or 29th highest hourly volume or annual average hourly volumes. So what is the correct criteria? So the highway facilities are generally designed for 30th highest hourly volume. Let's see more about the speed criteria also. So what is 30th highest hourly volume? This is nothing but the hourly volume which exceeded only 29 times in a year. So only 29 times in a year this volume gets exceeded. Only 29 times in a year this hourly volume gets exceeded. You can refer this graph. So this is the 30th highest hour. So 29 times in a particular year or in 365 days, this volume gets exceeded. And let's see other important things. According to IRC, rate of growth of traffic shall be considered as 5 to 7.5 percentage per annum. This is some codal provisions. And then there are some speed criteria. Let's say that also 98th percentile speed is considered for highway geometric design. So 98 percentage or we can say 98th percentage speed is considered for highway geometric design, and 15th percentile speed is the minimum speed criteria that is used to avoid congestion. So if the minimum speed is lower than 15th percentile speed, then there will be traffic congestion happens. For example, if you take pulling rickshaws and pulling carts, so that will have very low speed criteria. So that will be avoided by using 15th percentile speed. So to avoid congestion in a highway stretch, 15th percentile speed is the minimum speed that has to be followed, and 85th is the maximum upper limit speed for the regulation. For to control accidents or something else, there will be some upper limit for regulation. That is nothing but 85th percentile speed, and 50th percentile speed is nothing but median speed, the median speed one. So this is based on the graph between cumulative percentage of vehicle versus speed graph. Cumulative percentage of vehicle versus speed graph. In this graph we get 98, 85, 15th percentile speed. Now let's move on to fifth question. Which of the following is a warning sign? Warning or cautionary sign. Option A one way, option B speed limit sign, option C cycle crossing, option D parking. So which is a warning sign? There are many kinds of signs. For example, prohibitory sign and cautionary sign and informatory signs like that. And here we have to find what is a warning sign among these four options. So cycle crossing is a type of warning sign. It's a warning sign. Example for warning sign. So what is mandatory or regulatory sign? This, for example, we can say stop sign. Stop sign is a octagonal shaped signboard, and give way is inverted triangle. These are all some mandatory or we can say regulatory sign. Speed limit is a circle. You can see in this diagram speed limit sign and horn prohibited sign. These are some examples for mandatory or regulatory signs. And there is some other sign called cautionary signs, or we can say warning signs. One is cycle crossing, we have seen in this question. And others are right hand curve, pedestrian cars crossing, men at work, steep ascent, narrow bridge. These are some warning signs. We have to be careful when we crossing these stretches. And informatory signs are nothing but direction. Whenever there is a hospital location, one informatory sign has to be provided. And petrol pump, parking. These are some informatory signs. A traffic sign should not have more than 3 words. This is one basic criteria to be followed in case of traffic sign installation. So in a traffic sign, there should not be more than 3 words. Now let's see some other questions. Sixth question. Now let's see sixth question. A pre-timed 4-phase signal has critical lane flow rate for the first 3 phases or 190, 180, 200 vehicle per hour with saturation flow rate as 1600 vehicle per hour per lane for each phase. So they have given data for 3 phases and we have to calculate the data for fourth phase. That is nothing but the effective green time for fourth phase, and the cycle length is given as 60 seconds. So we have to adopt Webster's method to find the correct correct data, the effective green time for fourth phase. So as per Webster's method, they have to calculate this problem. They have given data for 3 phases and saturation flow rate is constant for all the phases. So the correct option is option A, 13.68 seconds. Now let's see how it is calculated. So Q1, Q2, Q3 are nothing but the flow rate, critical lane flow rate for first 3 phases. So Q1, Q2, Q3, and S is nothing but the saturation flow rate. It is constant for all the phases. So that's why S1, S2, S3 are equal to 1600. And as per Webster's method, cycle time is given as this formula. Given by this formula, C0 is equal to 1.5 L plus 5 by 1 minus Y. So what is L? It is nothing but last time. So let's assume 4 seconds last time per phase. So there are 4 phases. So that's why 4 into 4, 16 seconds as last time. So 1.5 into 16 plus 5 divided by 1 minus capital Y. How to calculate capital Y? By using this formula, summation of all the flow ratios. So flow ratio is given by this formula. Y1 is equal to Q1 by S1. So Q1 is 190, we know, and S1 is S1 and S2, S3 are one and same, 1600. So 190 divided by 1600 gives one answer. Similarly, we have to calculate for Y2, Y3, and capital Y is given. Capital Y is given as what? Capital Y is given as, sorry, capital Y is not given. We have to find using this formula. They have given cycle length is 60 seconds. So on substituting C0 L values, but we can find Y value. So capital Y is found, Y1 is found, Y2, Y3 all found. So Y4 alone is left. So Y4 is found by using this formula. So that is got as 0.16075. 0.16075. And we have to find the effective green time. We have to find the effective green time. That will be given by this formula. G is equal to Y4 by Y into C0 minus L. Actually, this is capital Y. We can say capital Y. C0 in minus L. And by substituting all those things, we get the answer as 13.68 seconds as the effective green time for fourth phase. Effective green time for fourth phase. This is how we have to calculate using Webster's method of traffic signal. Now let's move on to seventh question. Seventh question is based on Poisson's distribution. Vehicles arriving at an intersection from one of the approach roads follow Poisson's distribution. The mean rate of arrival is 900 vehicles per hour. The probability that the time difference between two successive vehicle arrivals is greater than 8 seconds is what? Option A 0.2653, option B 0.8756, option B 0.1353, option D 0.8647. So we have to calculate using Poisson's distribution formula. So it is a probability distribution. And it's also an exponential one. So Poisson distribution is used to calculate this problem. So the correct option is option C, 0.1353 as the probability value. Now let's see how it is calculated. They have given the mean rate of arrival, that is mean value is nothing but it is denoted by lambda, and lambda is equal to 900 vehicles per hour, and we need vehicles per second, so that's why VPH is converted into VPS. That will be nothing but 1 by 4 VPS. So Poisson distribution is given by this formula: P of n comma t naught is equal to lambda t naught par n e power minus lambda t naught divided by n factorial. So now we have to find the time difference between two successive vehicle arrivals in is greater than 8 seconds. So that's why n is 0 and time is 8. So on substituting all the things, so lambda we know 1 by 4, t naught 8 seconds. So 1 by 4 into 8 power 0. So this term will get vanished. So e power minus lambda t naught. So e power minus 1 by 4 into 8. That is e power minus 2 actually. Divided by n factorial. 0 factorial is what? 1. So 0 factorial is 1. So only term is e power minus lambda t. So if we substitute this lambda and t values, we get the answer as 0.1353, or we can say 13.53 percentage. So this is how we have to calculate as per Poisson's distribution method. So generally these two things can be used if it is asked for time greater than some t seconds. So p of greater than t is equal to e power minus lambda t. If it is asked for less than 8 seconds or less than some t seconds, then p of less than t will be equal to 1 minus e power minus lambda t. So these two basic formulas can be used to find the answer. So this is how Poisson's distribution goes. Now let's move on to eighth question. This question is based on various types of speed and it is asked for time mean speed. So option A, what is time mean speed? Option A, average speed of vehicles in a certain road length at any time. Speed distribution of vehicles at a point. Average speed maintained by vehicles over a particular stretch of road. Option D, speed maintained by dividing the total distance traveled by total time taken. So what is the correct definition that suits time mean speed? There are many speeds like time mean speed, space mean speed, instantaneous, spot speed, like this. So what is the time mean speed? It is asked. Whether it is option A or B, C or D. So the correct definition goes here. Speed distribution of vehicles at a point is nothing but the time mean speed. Now let's see more about it. So time mean speed will be is given by Vt is equal to summation of V suffix I divided by n. So what is V suffix I? It's a spot speed at the ith moment. So it can be given as average of instantaneous speed of all vehicles at that moment. At that means ith moment. So at the ith moment, what is the speed? And another I2 and I3, that's we have to summation. We have to sum up all the spot speeds and divide by number of speeds we got. So that will give the answer for time mean speed. Now what is space mean speed? This is nothing but the harmonic mean. So harmonic mean of all the spot speeds. So Vs is equal to n by reciprocal of sum of reciprocal of all the instantaneous speed. And the relation between how TMS, that is time mean speed, and space mean speed, time mean speed will be always greater than or equal to space mean speed, because time mean speed is a arithmetic average, a simple average. The space mean speed is given for harmonic average or harmonic mean. So always a simple averages will be greater than harmonic mean. So that's why TMS, that is time mean speed, is greater than space mean speed. And there is another relation regarding standard deviation and variation. Vs is equal to Vt minus sigma t square divided by Vt. So sigma t is the standard deviation, sigma t square is nothing but variation. So Vs is equal to Vt minus sigma t square by Vt. So these are some important relations between time mean speed and space mean speed. Now let's see ninth question. Now let's see ninth question. Ninth question is based on conflict points. So number of potential conflict points in the case of both the roads of intersection having two lanes, two-way traffic. So like this, two ways, two-lane traffic. Sorry, two-lane and two-way traffic. So what are the number of, how many number of conflict points are there? So among the four options, what is the correct option? Just refer this diagram and count the number of dots and get the answer. 32, 24, 26, 18. So what is the correct number of potential conflict points? So the correct number of potential conflict points is 24 in this case. Now let's see other cases. So if number of lanes of one road is 2 and another road is also 2 for both two ways, then it will be 24. And one is one way and another one is two way, then it will be 11. And if both are one ways, then it will be 6. Likewise, other things has to be followed. You can draw a diagram like this to get the number of conflict points. Instead of mugging up those values, these values you can memorize, or you can draw this diagram so that you will get the answer. For example, in this case, two-way, a two-lane two-way road. Here you can count this 4 dots. Here also 4 dots. So 8. Here 3. So 11. Here 3 dots. So 14. Here 1. Here 1. So 16 dots. 16 plus 2, 18. 18 plus 2, 20. 22 and 24. So counting all the things, we will get the answer for this scenario as 24. Likewise, you can draw this diagram, conflict diagram, for other scenarios. For example, two roads, two lane in a road and four lane in other roads. Then what are the number of conflict points? You have to draw this diagram and get the answer. Now let's move on to last question. Last question is an important concept behind rotary intersection. A roundabout is provided with an average entry width of 8.2 meter. So entry width of roundabout is given as 8.2 meter, and width of weaving section is given as 15 meter, and the length of weaving section also given as 40 meter. Crossing traffic is 1100 PCU per hour, and the total traffic in all the directions is summing up to 2200 PCU per hour. Now we have to find the capacity of roundabout. So there is one formula regarding roundabout or rotary intersection. We have to use that formula to find the correct answer for capacity of roundabout. You can pause this video and calculate it and check it. So the correct capacity of roundabout in this scenario is option A, 3937. Now let's see how it is calculated. So W, small w value is given as 15, that is nothing but width of weaving section, and E is nothing but 8.2, that is entry width. So W, E are given, length of weaving section as 40 meter, and P is nothing but weaving ratio. Weaving ratio is given by this formula. Weaving ratio is given by this formula. B plus C is nothing but weaving traffic divided by A plus B plus C plus D is nothing but total traffic. So they have given weaving traffic or crossing traffic as 1100, total traffic as 2200. So 1100 by 2200 gives the answer as 0.5, that is nothing but the weaving ratio, that is noted by small p. And this is the capacity formula adopted in a roundabout or rotary intersection. So capital Q is equal to 280 W into 1 plus E by W into 1 minus P by 3 divided by 1 plus W by L. So we know small w value, E, P, L, all the things known. Just substitute with proper units to get the answer in PCU per hour. So the answer is 3937. So let's see some other important points regarding rotary intersection. So width of weaving section shall be around 6 to 18 meters. So width of weaving section shall be 6 to 18 meters. This is a general uh, assumptions. And E by W ratio shall be 0.4 to 1.0. And how to calculate small w or width of weaving section by using this formula: E1 plus E2 by 2 plus 3.5. E1, E2 are entry width and entrance width like that. So E1 plus E2 divided by 2, that is average of these two, width plus 3.5 gives the width of weaving section. And W by L ratio, that is nothing but this denominator value. W by L ratio shall be 0.12 to 0.40. And length of weaving section shall be 4 times width of weaving section. So you can see here also. So here length of weaving section is 40, width of weaving section is 15. So 15 into 4 gives the answer as 60, around 60. So you can adopt 60 meter or less than that. But in the question they have given 40 meters length of weaving section. So that's why L is equal to 40 meter. But in case they have not mentioned about length of weaving section, we can find that value using, but that value by multiplying 4 times the weaving section width of weaving section. An entry angle shall be greater than exit angle. So for example, this is the entry point, and this angle shall be greater than exit angle. For example, 60 degree, 30 degrees. And radius of central island, so this is the central island radius, so that radius shall be 1.33 times the radius of entry curve. And radius of exit curve, for example, this is the exit curve, and that radius shall be 1.5 to 2 times the radius of entry curve. And this is the weaving ratio, and that shall be 0.4 to 0.9. So these are some important points regarding rotary intersection. So we have studied many concepts by answering 10 questions regarding traffic engineering. So if you like this video, please like, comment, share with your friends. Thank you.